What is tensile stress, and how does it cause materials to fail? Imagine pulling on a rubber band until it snaps. That tension is a perfect example of tensile stress at work. When materials are stretched, they experience forces trying to pull their molecules apart. Tensile stress is the force applied per unit area that causes this stretching. It is calculated by dividing the force applied perpendicular to the surface by the cross-sectional area of the material. The units used are pascals or newtons per square meter. When a material is under tensile stress, it can respond in different ways. It might stretch elastically, meaning it returns to its original shape once the force is removed. Or it could deform plastically, meaning it changes shape permanently. If the tensile stress exceeds the material's capacity, called the ultimate tensile strength, the material will break. Different materials fail in different ways. Brittle materials like glass or ceramics tend to break suddenly with little warning. They usually reach their maximum tensile strength just before breaking, so they don't stretch much beforehand. Ductile materials like steel or copper can stretch a lot before breaking. They undergo significant plastic deformation, giving warning signs before failure. Understanding tensile stress helps engineers design safer structures. They perform tensile tests to find out how much stress a material can handle before breaking. This helps in choosing the right materials for bridges, airplanes, or even tiny electronic parts. If the tensile stress on a part becomes too high, it can lead to mechanical failure, which might cause accidents or costly repairs. Calculating stress involves knowing the force applied and the area over which it acts. For example, if a steel wire with a cross-sectional area of 10 square millimeters is pulled with a force of 1,000 newtons, the tensile stress is 100,000 pascals. This number tells us how close the material is to its breaking point. By understanding how tensile stress works, we can predict when and why materials might fail under tension. This knowledge allows us to design products that are stronger and more reliable. It also helps prevent unexpected breakdowns in everyday objects, from car parts to bridges. So, next time you see a cable holding up a bridge or a wire in your home, remember that tensile stress is what keeps them from snapping under pressure.